Hello and welcome back. Let's talk about matrix algebra. So in the last video we talked about what is a regular matrix, what is a augmented matrix, and what they mean. So I guess I should reiterate a regular matrix, say, I have it up here. Here we go. A equals 1, 2, 3, 4. That's a regular matrix. It's really just a set of numbers. Now these sets of numbers could mean something. We could have, say, the rows represent different stores. Say this is the local supermarket. I'll write it on the side actually. And this is the local flower shop. And we could say that these rows are, let's say, flowers sold. And this one could be bushes sold. We could say maybe this is total flowers and bushes sold. Anyways, that's basically all we really need to know, is that these regular matrices are just sets of numbers. But sometimes we will want to know different things. We could say we have another matrix B, and we'll call that 5, 6, 7, 8. Not very creative here, but we'll get the idea. And so we could say maybe, as we had the supermarket and the flower shop and the flowers sold and the bushes sold, but maybe we have a flower shop and a supermarket in a different town, or say we had a city and there was 2 towns in the city, and we wanted to know the total flowers and bushes sold by every flower shop and every supermarket in the city. So this could be the flowers sold by the supermarket in, let's say, we could say these are the total flowers sold in the East City, or in the East supermarket and the East flower shop, and this could be the West supermarket and the West flower shop, and these are both still total flowers sold, total bushes sold, and the same for this matrix. So how would we figure out the total flowers and bushes sold in the entire East and West of this city? Well, we could say that that's matrix A plus matrix B. And so all that adding matrices is going to do is it's going to take this and this, the first row and first column, and the first row and first column, and we'll add them together. So 5 plus 1 is 6. Easy. Second row, first row, second column, we have 2 plus 6, that's 8. Second row, first column, on both of these we have 3 and 7, that's 10. And second row, second column, we have 4 plus 8, that's 12. So matrix addition is very easy. Now, what if we wanted to know how many more flowers does the west side of, or flowers and bushes does the west side of the city sell compared to the east side of the city? Well, that would be matrix B minus A, which we're just going to take our values and minus them from each other. So 5 minus 1 is 4, 6 minus 2 is also 4, 7 minus 3 is also 4, and 8 minus 4 is also 4. So this means that both the supermarket and flower shops sell 4 more flowers and bushes compared to the east side when we're talking about the west side. So that's pretty simple stuff. But now we'll talk about multiplying matrices. Now, multiplying matrices, we need to learn something called the dot product. Let's say we have a little set of numbers 2, 4, and we have another set of numbers 3, 1. And these are very simple matrices, although they are still matrices. You'll see later in the course, or in this set of videos, that we will talk about these being vectors. Now that's not even a part of this unit, so don't worry about that yet. What a dot product is it's just represented by a little dot here. And now you have probably seen this in earlier mathematics courses where it could be replaced with an X, say. Although, be very careful, because in linear algebra, these mean very different things. The dot product, this will basically, it's kind of like distributing, like we may have did in our high school mathematics. What we're going to do is 2 times 3 is 6, and 4 times 1 is 4, so we're going to add 4 onto that. This will be 10. That is the dot product of these two matrices. Now, we don't want the dot product of these two matrices, A and B. What we actually want is the matrix multiplication. Now, you will see why I showed you the dot product very soon. Now, applications of these multiplications get a lot more complicated, but I'll try to come up with something for you. Let's say we have the supermarket and the flower shop again, and this is total flowers sold per hour, and this is total bushes sold per hour. So we could call these plants. That's not how you spell plants. Plants per hour. And let's say we wanted the total plants, or the total bushes and flowers. We could multiply this by hours over, let's say, total. Or we could just multiply it by hours. So we could say that B is the amount of hours that the supermarket and the flower shop run for in each category, the plants and the flowers and the bushes. So now we want to know the total. Well, what this is going to be is we represent it just by A, B. Be sure not to put a dot or an X in between these, or a cross. By a cross, I mean the same thing as an X, because those represent very different things. So let's multiply these. So what we're going to get is we're going to take our rows from A, and we're going to take our columns from B, and we're going to distribute them. I'm going to make this matrix a lot bigger. In the first row of AB, we're going to have the rows of A. And in the second row, we're going to have the second rows of A. We're going to dot product all of these with the columns of B. So first column of AB is the first column of B. 5, 7. 5, 7. And then what we'll get here is the second row, or second column of B, 6, 8, and 6, 8. And we will use our knowledge of dot products that we just acquired. 1 times 5 is 5, plus 2 times 7 is 14. 1 times 6 is 6, 2 times 8 is 16. 3 times 5 is 15. 4 times 7 is 28. 3 times 6 is 18. 4 times 8 is 32. You're really going to need to know your mental math for these. And I'll admit, I'm not the strongest. Now, 5 plus 14, 19. 6 plus 16, 22. 15 plus 28, that will be 43, I believe. 18 plus 32 will be 50. So this is our total flowers and bushes produced, let's say, per day. This is the hours per day that they run. Yeah, produced by each market. So I hope this helped. Thanks for watching. I know sometimes these can get a little slow. We will definitely speed things up as we go on, but just get these down so that when I do get into those things, you don't have to go back videos and remember what's a dot product, what's a matrix, multiplication, addition, subtraction. We just need to keep those in our heads so that you can just trust me when I do things further on in this series that I got it right. Maybe I didn't, but as long as you understand how I got it, you got it. So thanks for watching again.